So let's start talking about the first few topics in Chapter 13 and Chapter 9 of the Mortgage Brokers course. Now, one of the first questions that kind of comes up when we talk about mortgage finance and interest rates and mortgage calculations and all these sorts of things has to do with debt. So primarily we're thinking about, well, why are we dealing with debt? Why do we have to deal with interest rates and mortgage calculations and all of these kinds of things? Well, there's a number of reasons that we deal with these questions in these courses. If we think very generally about, why do we deal with debt? What's the benefit of debt? Well, I think we all know the main benefit of debt. We use debt so we can consume now and pay later, right? We all want to consume now and pay later. So that's the primary benefit. In terms of, real estate, well, we want to benefit from the real estate now. We want to either, live in that house and benefit from the utility the house provides for us. And we're going to pay for it over time, right? And we need debt to do that. We know that real estate has a high cost, certainly in our part of the world, relative to incomes. So it's difficult to afford. So borrowing is one way, of course, to accomplish that. We know the length of time we would typically have to save to buy real estate outright is long. We might be able to save for 30 years and then buy a condominium outright, but then during that 30-year time frame, where are you living, right? So we know it takes a long time to save to buy real estate. So debt is useful. Other reasons include things like capital appreciation. You might want to buy a property and hope it appreciates or goes up in value. That might be a benefit to you in the future. You might buy real estate using debt as a hedge against inflation. That's an important reason as well, particularly when inflation is high. In the last few years in Canada, inflation's been low. So it hasn't really been a big driver. But historically, there's been times when inflation has been high. Using debt to buy real estate can make a lot of sense. Now, for most residential mortgage loans, most residential transactions rather, debt is used, and almost all commercial real estate transactions. So debt's part of the majority of real estate transactions that happen. You certainly see some all-cash offers sometimes for residential real estate. Empty nesters sell their house, and they buy a smaller house, and they downsize, and they've got cash, so it's an all-cash offer. But that's not the majority. Same for commercial real estate. Most commercial real estate is purchased with debt. So we have to deal with debt in pretty much any industry that's related to real estate, loans, borrowing, development, and so on. Debt requires interest payments. Interest is, by definition, a fee charged for the use of capital. So it's the price you pay to use somebody else's money so that you can buy some real estate asset and enjoy it, either its utility because you're living there, or enjoy some financial benefit that's derived from that asset in the future. So we need to talk a lot about interest rates, mortgages, mortgage calculations, and so on. Now, there are a couple of different kinds of interest, and I want to cover those first before we get into any calculations. The two primary ways to calculate interest are simple interest and compound interest. If we look at simple interest, I'll just provide a short definition, and there's a similar definition in the back of your materials like this. The definition of simple interest is like this. The definition says interest, so the cost to borrow money, is calculated on the principal. And the principal is the amount that you borrow. It's the loan amount. The principal is the amount that you have to repay. So interest is calculated on the amount that you borrow, and it's payable only once during the term of the loan, and for our purposes, that's at the end. Interest does not accumulate on interest already owed. Now that's different from compound interest. Let's look at a definition of compound interest and see how it differs. Under compound interest, the definition is interest is calculated on principal, just like it was for simple interest, and it's calculated on interest. And it's calculated every period. So we have to pay attention to how many periods there are in every loan. Interest is calculated every period. It accumulates. Interest for the next period is based on the outstanding loan plus the interest that's accumulated during the first period. So it grows or accumulates or compounds over time. So that's where the word compound comes from. So let's look at this in a little bit more detail. If we're to calculate simple and compound interest, we need some tools. We need some equations to do that. So let's look at a couple of simple equations to help us calculate simple and compound interest. So we looked at some interest calculation equations. To find the interest, or the dollar cost of borrowing money, over a period of time, we can use this equation. And so I represents interest. So that's the dollars. Well, what else is in there? If I is the dollars, the cost, dollar cost of interest, PV is the present value. And the present value is how much you borrow. So it's the principal amount, it's the loan amount, it's the amount that we borrow today. So the interest we pay is equal to the present value of the loan. If we borrow $100,000, present value is $100,000. Multiplied by small I. What's small I? Well, small I is the interest rate per period. So that's the cost of the money, and it's expressed per period. So again, we have to pay attention to what the periods might be. It might be a monthly period, it might be a weekly period, or the period might be a year. Last term is N. So it's interest is equal to the present value times I times N. So what's N? Well, N is the number of compounding periods. So N is time. It's expressed in compounding periods. You might say it's 1 year. We might say it's 52 weeks. We might say it's 12 months, and so on. So interest, how much you pay, is equal to how much you borrow times the rate, the cost of the money, times how long you borrow it for. That makes a little bit of sense. The more that you borrow, the more interest you'll pay. The higher the interest rate, the more interest you'll pay. The longer you borrow the money, the more interest you'll pay, and so on. So this equation very simply gives us how much interest accumulates. Another equation that we can use allows us to find, well, we borrow $100,000 today. What do we owe in the future at the end of the loan? So another simple equation will give us the future value. And the future value equals the present value, what we borrowed, you have to pay that back, plus the interest that accumulates. So the future value simply equals the present value plus the interest. And we'll use these two equations in a calculation of simple and compound interest next. So let's look at a very simple example. We'll calculate do an interest calculation. Simple example is this. Let's borrow $400 for 3 years at 9% per year. So we're dealing with yearly periods. And I've said assume no payments. So we're not going to make any payments during this loan. We're simply going to borrow the $400 today, and we're going to pay it back at the end of 3 years. The question is simply, what amount is owed at the end of the 3-year loan? Well, we're going to do this calculation twice. We're going to do this calculation using simple interest and compound interest. So let's do that. So this is the loan term. Borrow $400 for 3 years at 9% per annum. And we're looking for what the future value is, what's owed at the end of the loan. Well, we're going to look at this loan under simple interest and compound interest. And we're going to use those equations we just talked about to do it for us. So if we think about the definition of simple interest again, the interest is based on the principal, and it's calculated only once at the end of the loan. So if we look at the 3 years of this loan, well, year 1, there's nothing paid. Year 2, same thing, there's nothing paid. Everything gets paid at the end of the 3rd year. So let's look at the end of the 3rd year. Well, what happens at the end of the 3rd year? Well, let's calculate the interest. Well, we know the interest is equal to the present value multiplied by the interest rate per period times the number of periods. So let's fill in the blanks. The present value is $400. The interest rate is 9% per annum. And that's 9 as a percent. When we use it in an equation, we have to use it as a decimal. So that's 0.09. So if you wanted to, you could put 9% in your calculator, hit that percent key we talked about, and it would make it 0.09. And you could use that. Or you just know that to move from a percent to a decimal, you move the decimal over 2 spots, and it's 0.09. So it's the interest rate per period or per annum or per year, which all mean the same thing, multiplied by the number of periods. There's 3 periods in this loan, 3 years. So 400 times 0.09 times 3 gives us $108. We're looking for how much is owed at the end of the 3 years. The amount that's owed at the end of the 3 years is the future value. The future value goes to the present value plus the interest we just calculated. So the present value is $400. The interest we just calculated is $108. So again, it gives us a future value of $508, and that's the amount that we have to repay at the end of the loan. So borrow $400 today, 3 years later, pay back $508, and you're done. Now that's using simple interest, and the calculation is fairly simple. What I want to do next is look at compound interest. We'll do the same kind of calculation, but based on the definition of compound interest, which is a little bit different. We'll see how the calculation changes, and we'll see how our answer changes. So let's do the same kind of calculation using compound interest. Now we know the definition said interest is calculated on the principal, and it's calculated every period. Well, how many periods do we have? We've got 3 periods. It's a 3-year loan, annual interest rate, so 3 periods. So we'll have to do this calculation 3 times. Well, the first year, so I put I with a small 1 beside it to indicate the interest that accumulates in the first year. Same equation. Present value is $400 times the interest rate, 0.09. But because we're just dealing with the first year, it's times 1. It gives us 36. So that means $36 worth of interest accumulates in the first year. Well, what's owing at the end of the first year? Now, we need to know what's owing at the end of the first year because the future value at the end of the first year will be the present value at the beginning of the second year. So let's do a future value calculation. Well, the future value at the end of the first year is the $400 you started with, plus the $36 in interest that's accumulated in the first year. That gives us a future value of $436. Right. So that's the end of the first year. Well, let's look at the second year. The interest calculation for the second year is very similar. It's the present value times I times n. But the present value has changed now. The present value at the beginning of the second year is the same as the future value at the end of the first year. So our present value has risen. So it's now $436 times the interest rate, 0.09, times 1 more year, gives us $39.24. That's how much interest accumulates in the second year. So right away you can see, wow, interest is growing. It was $36 in the first year, $39 in the second year, and you can bet it's going to be even more in the third year. So that growth is the compounding. That's what compounding is. So let's finish off the second year. We'll need to know what the future value is at the end of the second year. So $436, which is our current present value at the beginning of the second year, plus the interest that accumulates in the second year, $39.24, gives us $475.24. So we'll do this calculation one last time for our third year. Same calculation, numbers change a little bit. The end of the third year, we'll take our new present value, and the present value at the beginning of the third year is the same as the future value at the end of the second, calculated a moment ago. It's now $475, and times 9%, times 1, gives us interest of $42.7716. Future value calculation, what's owed at the end of the third year, which is the end of the term, simply $475 plus the $42 in interest gives us $518. So notice a few things here. First of all, that under compound interest, we owe more at the end. We owed $508 under simple interest and $518 under compound interest. So if you're a lender, what kind of interest do you charge? Well, you might think compound interest looks pretty good because you're going to get more money back. It's going to result in more interest being owed and more interest being paid, and that's exactly right. So that's exactly what happens. So that's the first thing. So that's the difference between simple interest and compound interest. Compound interest has this growth, this compound growth accumulation during the life of the loan. And the second thing you'll notice was doing it this way with all these steps was a lot of work. Right? This was a lot of effort. This is only a 3-year loan, but it was a 30-year loan. You had to do this 30 times. Well, none of us would want to do that. I don't want to do that. I don't think you want to do that. Well, fortunately, we don't have to do that. This illustrates how compound interest works very nicely, but there are better or easier ways to calculate the future value of compound interest.